17,000 light-years from where you are sitting right now, something in the darkness of space looks exactly like a hand. Fingers, a palm, a wrist trailing off into emptiness. And at the very center of that palm, buried inside the glow, spins an object barely 20 kilometers wide that somehow outshines stars 1,000,000 times its size. Astronomers didn't go looking for this. They found it by accident, hidden in X-ray light invisible to the human eye. And the moment they processed the image, the same question came back again and again in observatories across the world. How can something like this exist? This isn't a hand reaching out from the heavens. Nothing about it was designed. And yet the more you learn about the physics behind it, the harder that becomes to believe. I'm Captain Vega. I've spent years chasing the strangest shapes the universe has ever produced. Collapsed stars, impossible magnetic fields, light bent by gravity itself. But this one, the object some call the Hand of God, still stops me every time I look at it. Today, we're going to find out exactly what's casting that shadow across the southern sky. Let's start with what we're actually looking at, because the name is almost a trick. There is no hand. There is no God reaching into our galaxy. What astronomers photographed is something called a pulsar wind nebula, and to understand it, we have to go back to 1982, when a satellite called the Einstein X-ray Observatory picked up a faint, rapidly pulsing signal coming from the constellation Circinus, deep in the southern sky. That signal had a name, PSR B1509-58, a pulsar.
Picture it. A star many times the mass of our sun runs out of fuel, collapses in on itself in a fraction of a second, and detonates as a supernova. What's left behind is a neutron star, an object so dense that a teaspoon of its material would weigh more than a mountain. This particular leftover core is only about 20 kilometers across. You could walk its entire diameter in a few hours. And yet it spins on its axis nearly 7 times every single second. That's not the strange part. The strange part is its magnetic field, roughly 15 trillion times stronger than Earth's. It's one of the most powerful magnetic fields ever measured around an ordinary pulsar, so extreme that physicists place it right at the border separating normal neutron stars from magnetars, the most magnetically violent objects known to exist. PSR B1509-58 sits almost exactly on that line. Astronomers still debate which side it truly belongs to. That spin, combined with that magnetic field, turns this tiny dead star into one of the most powerful natural generators in the entire Milky Way. It hurls out a relentless wind of charged particles, and when that wind slams into the gas left over from the supernova explosion, it lights up, not in visible light, but in X-rays.
That glow is what NASA's Chandra X-ray Observatory captured in 2009, revealing finger-like structures stretching roughly 150 light-years across, 15 times wider than the famous Crab Nebula's own Pulsar Wind Nebula. One finger appears to reach toward a neighboring cloud of gas called RCW-89, energizing it from a distance, almost as if it's pointing. Nobody designed that shape. Pareidolia, the same instinct that finds faces in clouds, is doing the rest, but the physics underneath it is entirely real and entirely strange. By the way, if mysteries like this keep you up at night the way they keep me up, this is exactly the kind of investigation I run here, week after week. Stick around, because the deepest part of this story is still ahead of us. Now here's where things get genuinely uncomfortable for astrophysicists. When a young, energetic pulsar like this one was discovered, scientists expected it to behave like its famous cousin, the Crab pulsar, blazing brightly in high-energy gamma rays. Instead, when NASA's Compton Gamma Ray Observatory and later the Fermi telescope searched for it, the signal at the highest energies was almost absent. That shouldn't happen. Every other young, powerful pulsar like this one lit up in gamma rays. This one barely did. Two competing explanations emerged, and astronomers still haven't fully agreed on which one is right.
The first, championed by researchers including Alice Harding and her colleagues, proposes something almost science fiction in nature. In a magnetic field this extreme,
Gamma-ray photons can physically split into two lower-energy photons before they ever escape, a quantum effect called photon splitting, predicted by theory but rarely observed in such dramatic form. The second explanation, proposed by physicists Zhang and Chang, suggests the emission instead comes from a completely different region, farther from the star's surface, called the outer gap, where electrons scatter light through a process called synchrotron self-Compton radiation. Both explanations fit the data reasonably well. Neither has been definitively proven, and that's the kind of open question that frankly keeps this field exciting. Personally, I've always found it remarkable that an object only 20 kilometers wide can force some of the smartest physicists on the planet to argue about quantum electrodynamics. Every time we think we understand pulsars, one of them breaks the pattern. There's more. Brian Gansler and his team, examining the Chandra data closely, identified a narrow collimated feature streaming from the pulsar that they interpreted as a relativistic jet fired directly along the neutron star's spin axis, material moving at a significant fraction of the speed of light. Multiple Chandra observations taken years apart in 2004, 2008, and again between 2017 and 2018 have even allowed astronomers to track this entire structure drifting slowly across the sky, evidence of the pulsar's own motion through space since the moment of its birth. And then, in 2023, came the revelation that genuinely surprised the astronomical community. A team led by Roger Romani used NASA's Imaging X-ray Polarimetry Explorer, IXPE, to measure something no instrument had ever measured here before: the orientation of the magnetic field itself, traced directly from the polarization of the X-ray light. What they found was almost unbelievable. In arcs surrounding the pulsar and along sections of that jet, the polarization degree exceeded 70%, approaching the theoretical maximum physically possible for this kind of radiation. It meant the magnetic field in those regions wasn't tangled or chaotic at all. It was extraordinarily ordered, almost architectural in its precision, while at the base of the jet, the field suddenly turned messy and complex, twisted at odd angles to everything around it. Astronomers still don't fully understand why one part of this dead star's wind is so perfectly organized, while another part just light years away is in chaos. So is the hand of God simply pareidolia, dressed up by physics? In one sense, yes. But in another sense, the real story is more astonishing than the illusion. A neutron star smaller than most cities is bending light, splitting photons, and organizing magnetic fields across 150 light-years of space, using nothing but its own spin and a few seconds of supernova violence from 17 centuries ago. Every time we study an object like this, the line between the impossible and the merely unexplained gets a little thinner. We came looking for a hand in the sky, and we found a dead star still writing its own physics, light year by light year, into the void.
If this is the kind of mystery that pulls you in the way it pulls me in, the universe has another one waiting. A pulsar's twin, in fact, blazing in the northern sky with its own impossible secrets. Join me there next in our investigation of the Crab Nebula, and let's keep asking how any of this can possibly exist.